All right, I just finished with part 2. Now we're going to go on to part 3. I'm going to graph one more. Now, quadratic functions can get kind of hairy sometimes, like this. Now, the reason why this one's going to be a little bit hairier than the other one is because we have a -2 for the a. It's not a positive 1. Okay, you see the -2 over here as well. Okay, so the first thing I'm going to do is find my vertex, right? Because we only need 2 points to graph a quadratic function. So to find our vertex for the first one, since it's in vertex form, we just have to look at the two numbers right here, the h and the k. Now, our h right now looks like it's positive, but it's not. You have to remember the original form says -h. So that means this is actually a -5. So we have a -5, 1. And we find the vertex, it's done. Man, that was super easy with the vertex form. Not so easy with the standard form. With standard form, we have to first find the axis of symmetry. So to find the axis of symmetry, we use our formula, -b/2a. We have a blank right here for the b. The b right now is -20, so I'm going to plug that in. The a is -2, that's out in front. We simplify, we get 20 over -4, which gives us -5. Now, if we want to find the y value, we're going to have to take that -5 and plug it back into the original function. So now we have -2 times -5 squared, and then -20 times -5, and then we have the -49. Make sure you multiply, do all your multiplying, or power, then multiplying all first. Do you follow the order of operations? So I did the power first. I also multiplied this one because the power had no effect on it. And then, let's see, I get -50, 100, and -49. When I add that all together, I get 1. Hey, just like over here. Oh my gosh, but this one was so much easier. Okay, so I have -5, 1 is my vertex. Now I just need one other point, just one other point. Now, we could find a point that's close to the vertex, or we could find the y-intercept. I'm going to find a point that's close to the vertex first, so I'm going to pick -4. When I plug in -4, I get something that looks like this. -4 plus 5 is going to be -1. I'm sorry, +1, and then I go +1 squared, which is just 1, then I have -2 plus 1, which gives me -1. There you have it. I have my other point. Okay, now let's see what that looks like over here for the standard form. We're going to do the same thing. I'm going to pick -4. Now, you can pick -4 or -6. It doesn't matter, just as long as you stay close to the vertex, as close as you can. When I plug in the -4, this is what it would look like. Don't forget your parentheses. I take care of the power, then I start multiplying. I get -32 plus 80 minus 49, and then I get 48 plus 49, which gives me -1. I'm sorry, 48 minus 49, which gives us the same point. Okay, now we have our other point. Now we have our axis of symmetry. We can just copy this point over to the other side, and then you have your parabola. Now, if you didn't choose the point, another point that's close to the vertex, you could have chose the y-intercept, just like we noted before. Now, the y-intercept has a 0 for the x, and remember, that's the point on this line that crosses the y-axis. I'm not even going to bother plugging this into the vertex form because I'm getting tired of this video. I'm just going to plug it into this one because whenever you plug 0 into standard form, it's like super easy. See, check this out. I plug the 0 in. Look what happens. I get 0 minus 0 minus 49. Obviously, that's -49. And you get the same thing if you plug it in the vertex form over here. Now, -49 is off my graph, and so I can't even use the y-intercept on this one. That's why a lot of times I just use the number that's closest to the vertex in order to find my second point. But that's all you need, guys. You need 2 points to graph a vertex form because you know about the axis of symmetry, and then you're done.